So let's talk about direct variation and inverse variation. If two things are related, such that if you increase one of them, the other one increase, then they have direct variation. For example, think of fire and gasoline. Well, the more gas you add to the fire, the more fire you're going to have. So it has direct variation. On the other hand, if you have fire and if you add water to it, the more water you add to it, the less fire you're going to have. So it's going to have inverse variation. For the purpose of our class, we use y equals k times x. Two things to remember: k cannot equal 0. Obviously, if k is 0, then everything is 0, and that's like not interesting at all. And k is a constant. K is a constant of proportionality, and it is not 0. So the formula for direct variation is just simply y equals k times x. For inverse variation, we have y equals k divided by x, or you could think of it as y equals k times 1 over x, the inverse of x. Okay, again, k is a constant and k cannot be 0. So let's go to the next page. So write an equation for each statement. Number 1, A varies directly as B. So A equals some, since it says directly right here, so A equals K times B with K being a constant. How about number 2? F varies directly as H. Well, again, directly. F equals H, K times H, with understanding that K is a constant. Let's go to the next page. Number 3, A is jointly proportional to B, C, and D. Okay, so A equals K times B and C and D. I shouldn't say and, I should say K times B times C times D, because and in math means addition. So K times B times C times D, with the understanding that K is a constant. Number 4, E is inversely proportional to F. Since it says inversely, then I have E equals K times 1 over F, or K divided by F. And K is a constant. Let's go to next page. Y is jointly proportional to the square of X and Z. If X equals 2, and Z equals 1/3, Y equals 36. Notice that in this problem, it didn't tell us that it is directly or inversely. It simply says jointly. So the word inversely or directly is not there. Anytime the word directly or inversely is not there, we are going to have to assume it's direct proportion. So once again, it's just like, it's just like in math, when you say x, x is to the power of 1. So if you don't write the 1, we assume the power is 1. If you don't write the 1 before x, we assume that the coefficient is 1. So in here, we assume that they're talking about direct proportion. All right, so since it is directly proportional to the square of x and z, y equals x to the second x squared times y squared. And now I'm going to go ahead and substitute 36 for y, because the problem is telling us if x is 2, z is 1/3, then y is 36. So y is 36. And so here I have to, I totally missed my k in here. Sorry about that. Y equals k times x squared times y squared. I need more coffee. Okay, y equals k times x squared times y squared. So 36 equals, when x is 2 and z is k times x squared, and I really need to be careful with that. I'm so sorry about that. Y equals k times x squared times z squared. Okay, so I got to slow down. Y equals k times x squared times z squared. So 36 equals k times 2 squared times 1/3 squared. So 36 equals 2 squared is 4 times 1/9 is 4/9. Multiply both sides by 9/4, and you get k equals 81. So the equation of proportionality is y equals 81 x squared z squared. Okay, good thing we caught that mistake. 81 times x squared times z squared. Let's see if I have more examples, and I do. In this example, we have t is proportional to the product of x and y. So it's direct and inversely proportional to r. When x is 2, y is 3, and r is 12, then t equals 25. So since t is, that means t equals proportional to the product of x times y, so xy, and inversely proportional to r, so divided by r. And so now we can go ahead and plug in the numbers. T is 25. If x equals to 2, and y equals to 3, and r equals to 12. So I do have 2 times 3 is 6, divided by 12 is 0.5 or 1/2. Multiply both sides of this equation by 2, and you get k equals 50. So t equals 50 times x, the product of xy over r. Okay, let's see. One more example, a word problem, something that you love. The stopping distance, d, distance of a car, stopping distance varies directly as the square of the speed s. So directly as square of speed s. And remember that the word directly didn't have to be there. We just have to, if it wasn't there, we have to assume it's direct proportion. So now we have a car that is traveling at 40 miles an hour. And that this car, let me put a comma here, and is capable, can stop in 150 feet. What is the maximum speed it can travel if it needs to stop in 200 feet? Okay, so let's go to the next page. First of all, we know that the problem told us that the distance is proportional to square of speed. So d equals k s to the second. And the problem told us that the car can stop at 150 feet if it's going 40 miles an hour. So plugging those numbers and solving for k, I get k equals 0.09375. So now I can write the equation of proportionality as d equals 0.09375. Okay, 75 s squared. So if distance equals 200, I'm going to set this d equal to 200. Going to the next page. So 200 equals 0.09375 s squared. So divide both sides by the coefficient of s squared, then take square root, put in your calculator, and you get 46.19 miles per hour. So the maximum speed to 2 decimals that this car can be traveling and being able to stop at 200 feet is 46.19 miles per hour. Okay, I'll be talking to you soon. Thanks.